Alright, number 34, four-pointer. In the diagram below of triangle RST, big triangle, one that people struggle to visualize, point L is on RS and M is on RT, such that LM is parallel to ST. And that is important because parallel lines create congruent angles. Congruent angles create similar triangles. So I know that this is a triangle similarity problem, which means before I do anything else, I'm just going to draw these triangles separately. I've got triangle RML, and I got the big triangle that I got the clue about in the problem, which is triangle RST. And what am I giving? RL is x minus 5. RS is equal to 9. ML is equal to 5. And TS is equal to x plus 7. So I'm saying similar triangles, which also means that there is a dilation, and the way that we have always solved these problems is by setting up a proportion where we match up the corresponding sides. And we've got these two sides corresponding, so I'm going to put them both in the numerator. The x plus 5 turns into the 9 when we do the dilation. And then we've got this side turning into this side, so the 5 is turning into the x plus 7. And now we've got the task of solving the proportion, which of course always means we are cross-multiplying. And I can already tell this is going to be a tricky one because we've got all these algebraic expressions, but always write the result of your cross-multiplying down. You got the 9 times the 5 is equal to the x minus 5 times the x plus 7. And I probably introduced this as like the area model, so I'm going to go back to that for distributing. So we've got to do the undo that. The x minus 5.
Good afternoon, this is Miss Yacenta with just a quick announcement and reminder
Announcements.
that tomorrow
Each one.
are scheduled for a science mock exam. And on Thursday, you are
Wait till the
scheduled for
announcement.
a
Feel free to
math
fast forward this
mock
part.
exam. If you don't have a research coming up this year, it is still required that you are in the building. Both days are testing days, but both days are attendance days. So please make sure you follow your schedule. You want to be here on time and ready to rock your mock. If you have any questions, come find me, email me. But let's do this. Thank you.
Sorry for the interruption. It is just 4 multiplication problems where whatever meets in that box is the product you get. So the negative 5 meets with the x. The nice thing about the area model is it just gives you a visual of all the different multiplication problems that have to happen. These ones are the like terms, and you just combine the coefficients, so it's basically 7x minus 5x, which gives you 2x. And that's what you get as you expand out this expression. So we get the 9 times the 5 is 45, and I have my x squared plus 2x minus 35. And here's where you do have to remember this very specific skill. The only way to solve this type of equation is to set it equal to 0, which means that I'm going to subtract 45 from each side, lining up my like terms, and I'm just going to move it up here to create some more room. I have now got my 0 on my left side of the equation, and I've got x squared plus 2x minus 35. And this is where you have to factor. You can visualize this factoring as like the reverse area model to figure out what the factors are. Sorry, I wrote this negative 35. That was a mistake. Got to combine that, the negative 35 minus 45. I think this is actually going to make it easier when this is a negative 80. So I know that I'm going to have to multiply to get negative 80. I know that I'm going to have to add up. These two things are going to have to add up to give me a positive 2x. And this part is going to have to be my x squared. So I know I've got my x and my x to get my x squared. And now it is a little bit of trial and error. Factoring part is a hard algebra skill, which is really what makes this a 4-point problem. So I'm looking for two numbers that multiply to negative 80 and add up to positive 2. I'm going to do one that's wrong and just see why. So if we do a 40 times a negative 2, that would give me a negative 80. But then I would have the x times the negative 2, which is negative 2x. And I would have the 40 times the x, which is 40x. And that is nowhere near adding up to. That's going to give me negative 38x. And that is not what I'm looking for. Hey, Jefferson.
I got a question for you. Where you going to meet next period?
Hayden interviews, 226. No worries. So this problem, one thing that I do know, because this number is way too big, is that these numbers are way too far apart. So even the wrong answers give you some clues. I'm pretty sure I know the right answer because the first thing that came to my mind when multiplying to 80 is 10 and 8. And I know 1 has to be negative. So if my goal is to add up to a positive 2, I'm going to say that that is positive 10 and negative 8. The 10 times the x gives me 10x. The negative 8 times the x gives me negative 8x. And those do add up to the positive 2x that we need. So what I'm staring at right now are my factors. We've got x plus 10 and we've got x minus 8. And when I multiply those two, they give me 0, which means the multiplication property is 0. It says that either the x plus 10 is equal to the 0 or the x minus 8 is equal to the 0. Got two straightforward problems to solve. Subtract 10 on both sides here, add 8 on both sides here, and you end up with your two possibilities. So either x is equal to negative 10 or x is equal to positive 8. But since we're trying to look for the length of a side, there's no way it's the negative number. So I've got that x is equal to 8. Now, I never annotated and figured out, determine and state the length of TS, which is over here. So since I got x equals 8, this becomes 8 plus 7. And so I get my final answer that TS is equal to 15. And seems pretty nice. Let me just check my work, because this would mean, if that's 15, that this is a scale factor of 3. And if x is 8, 8 minus 5 is 3, and 3 times 3 is 9. I now know that I got this problem right.